Hey, welcome back, students. In this video, what I want to do is show you how to find the molar mass of a compound. And as you can see, we've got three problems that we're going to be trying to solve today. And so let's just go ahead and jump right in and try to solve these. But as we go through this, we want to point out and make sure that we all understand what molar mass is. Molar mass of a compound is going to be the mass of 1 mole of a compound. And so essentially, what you've got here when you see these formulas like NaCl, NaOH, and MgCl2, which you got here in these three sections, is that each of these is essentially 1 mole of that compound, simply because if we look at the NaCl, this is actually NaCl like this, but there is an imaginary 1 that we see here in the front, and that represents that there is 1 mole of that compound. Just like we're going to see the same thing over here for the NaOH. We have NaOH here, right? And we also know that there is an imaginary 1, indicating that there is 1 mole of sodium hydroxide. And in the last case here for the MgCl2, we know that we're going to have MgCl2, and there is also an imaginary 1 at the beginning of this formula, indicating that there is 1 mole of MgCl2. So the molar mass then is going to be the mass of each individual atom in this compound. So it's going to be this mass, the combined mass, so the overall total mass of each. So what that means is that we're going to find the mass of the sodium and the chlorine, and we're going to add them together, and that will give us the overall mass for this one compound. And we're going to do the same process here for the sodium and the hydroxide, add the masses for those, and that will give us the mass of the compound. And the same thing for the magnesium and each of the 2 chlorines in the last example. So let's go ahead and begin, and we'll start with the very first one here. Our problem that we're looking at is NaCl, and we're going to try to find the mass of NaCl. And so we will begin by first looking at the atoms, and we know that we've got a sodium atom and we've got a chlorine atom. Now if you look at the individual numbers here, we know that we only have 1 atom of sodium and we only have 1 atom of chlorine. And so we're going to go ahead and find the mass of each of these 2 atoms, and we look on the periodic table, and we know by looking at the periodic table that sodium is going to have a mass of 22.990 grams. And if we look at the chlorine will have a mass of 35.453 grams of chlorine. All right, so what we do next is just go ahead and add these 2 numbers together, and in doing so, that will give us the mass of all the sodiums and all the chlorines for a combined mass of the entire compound, which is known as the molar mass. And so let me add those together, and we get 58.443 grams. And this is going to be the mass of the entire compound, and so this is going to be of NaCl. Okay, so this here is your answer. So we can go ahead and write the answer right over here. What is the molar mass of NaCl? And that is going to be 58.443 grams of NaCl. Let's go ahead and move on to the second problem. I'm going to change color of pen now. I'm going to go ahead and use red. And so we're going to look at identifying the mass of NaOH. And so looking at this, we notice that we've got 3 different atoms. We're going to have an atom of sodium, we're going to have oxygen, and a hydrogen in this particular compound. And so we look at the mass again for sodium. We notice that sodium has a mass of 22.990 grams. We know that oxygen has a mass of 15.999 grams. And if we look at hydrogen, hydrogen here is going to have a mass of 1.008 grams. And so we're going to go ahead and add each of these together. And when we do, that's going to give us an overall mass for this 1 mole of sodium hydroxide, which is our molar mass. And that mass is, okay, so that mass is going to be 39.997 grams of NaOH. And so this here is your answer there for the second problem. Okay. And looking at the third problem, what is the molar mass of MgCl2? Well, let's go ahead and figure that one out from the start. We know that here to begin with, we've got a magnesium atom and we've got chlorine as the other atom. However, here for magnesium, we've only got one, and for chlorine, we actually have 2 chlorine atoms. So we're going to have to multiply the mass of the 1 chlorine, we're going to have to multiply that by 2 so that we can get the overall mass for all of the chlorines in the compound. And so what this tells us here is that we're going to get a mass for magnesium to be 24.305 grams. And for the chlorine, we're going to get a mass of 35.453 grams. But remember, there are 2, so we're going to multiply this times 2 because there are 2 atoms in the formula. And so in case you're wondering, the 2 is actually right here in the formula. Write an arrow to it right there. Okay. And so when we multiply these two together, 35.453 by 2, the answer that we get here is going to be a 70.906. And then when we add the 24.305, the answer that we wind up getting here total, when we add these two combined, these amounts, we get 95.211. And this is going to be grams of MgCl2. And this is your last answer for this problem set. So finding the molar mass is not incredibly difficult, but remember, in summary, what you need to do is find the mass of each of the atoms in the compound, add them together, and that is your molar mass.